Okay, example 11 asks us to solve the simultaneous equations. So in this problem, we actually have two separate equations. Um, each of them has an x variable and a y variable. It doesn't really matter that they're labeled x and y, but they're just two different variables. Um, what we have to do is we have to make a statement, like a simple statement of relating x and y together. Um, for simultaneous equations, it's going to work to where we want to turn them into some form of a line. So we want something times x plus or minus something times y equaling something, or any sort of arrangement of them. So we want something that looks like a line, where we have a single y, a single x, and some extra term at all. Because what happens is when we have one line and another line, we can look for an intersecting point. Where do they have a common solution? And then that's how we solve these simultaneous equations. That's what we're going for. So we have to have the lines first. So if we look at kind of like our first equation here, we'll call that the first equation. So we'll have 32 to the x divided by 8 to the y equals 512. So how do we make that happen? Well, we need to use our rules of exponents. The big thing that we need to understand here is that they have different bases. All of these numbers have different bases. We have got to find a common base for them. Now, you know, normally look at your smallest one. Well, the problem is 8 squared is 64. That's too big for 32, so we have to look at another base. The only other base that would be possible at this point, you might be thinking 4, but that doesn't work because 4 squared makes 16 times 4 is 64. We would have to go to 2. And if you look, 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32, 2 to the sixth is 64, 2 to the seventh is 128, 2 to the eighth is 256, sorry, and 2 to the ninth is going to be 512. So what I have to do is I have to go ahead and I just want to physically replace each number that in there to have a base of 2 with some exponent. So 32, I'm going to replace with 2 to the fifth. Okay, so I'm going to say, okay, well, 2 to the fifth to the x. And I'm going to divide that by 8 to the y, so that's 2 to the third to the y. And that equals 512, which is 2 to the ninth. Now that they all have the same base, I can actually break them down and find that, and I can kind of stack them. So I move kind of just slightly over to the right. So this would be 2 to the 5x, if you remember our rules. And this would be 2 to the 3y, and that equals 2 to the ninth. Well, over here we have the two exponents stacked on each other. In order to make the left side look like the right side, what I'm going to do is I want to take my 3y and give it up to the top, or actually really take it away from the top. Our rule when we're dividing is to subtract them. So this will make 2 to the 5x minus 3y equals 2 to the ninth. And now that we have the same base, we can say 5x minus 3y equals 9. So this is not an answer, but we're going to come back and use this later. But this is that statement that I was trying to tell you to make, right? This is a line right here. It may not be in that y equals mx plus b form, but that is an equation of a line. Now the second one, we have 3 to the 3x. It's divided by 1 over 27 to the 1 minus y. That's interesting. And that equals 729. So again, this is a very similar looking problem, just a little different. So we have to find a common base for them. So our common base, it looks like we've got probably going to be 3. So right, you have 3 squared is 9, 3 cubed is 27. Realize, I know that's 1 over 27, but there's a little rule that I'll explain in just a second. And we have 3 to the 4th is going to be 81. 3 to the 5th, it's going to be times 3, so 243. And 3 to the 6th power is going to be 729. So first step, replace the things that we need to replace. So 3 to the 3x, that stays the same. Now, 1 over 27 is 1 over 3 cubed. Well, if you want to, one rule is if you ever want to flip something and make it a reciprocal, you just make the exponent, whatever it is, negative. So this is actually the same thing as 3 to the negative 3 to the 1 minus y. And then 729 is 3 to the 6th. So we're going to have 3 to the 6th power. So we're fairly close to what we had before. So this would make 3 to the 3x over. Now remember, we multiply the top, so we're going to have 3. Negative 3 times 1 makes negative 3. Negative 3 times negative y makes a positive 3y. And that equals 3 to the 6th. We're then going to subtract the top away, kind of just like we did in the previous part. So we're going to have 3 to the 3x minus a negative 3 plus 3y. And that equals, and let me make some more room, 3 to the 3x minus negative 3 plus 3y. That equals 3 to the 6th. So we can simplify this and write out an equation. We're going to have 3x plus 3 minus 3y equals 6. And we can say, okay, well, this is 3x minus 3y. We move the 3 over. We subtract 3 from both sides. We're going to end up with equals 3. So this is our second equation. And lots of writing, and it's lots of problem solving, but now we have the two equations that we want. So we have 5x minus 3y equals 9. And we have 3x minus 3y equals 3. So there's many different ways that you can go about this problem, but these are the equations that we're going to need in order to solve this out. So one way that we can do this is actually to create a, using our calculator, is actually create a matrix. And when we make our matrix, we're going to run something called a row reduction, and it'll solve it for us right there. If you have your polysim finder, it'll do the same thing. But whichever way you want to choose to do it, that's fine. So I'm going to show you how to do it with the matrix. So what we're going to do is look for the coefficients in this equation here. So our matrix is going to look like this. 5, negative 3, 9, 3, negative 3, 3. And that's going to correspond to our equation. Now what's going to happen is this is going to do a bunch of row reduction and solving for us. And what we're going to end up with is a matrix. So this is our start. And we're going to end with a matrix that looks like this. 1x plus 0y equals blank. So that will be x equals. And this will be y equals. So it'll say 0x plus 1y equals blank. And so these two answers here are going to tell us what x and y are going to be. So I'm going to load up my calculator. And I'm going to type in my information here. If it starts. Okay. Okay, so I need to go to enter my matrices. So I'm going to go to second matrix. I'm going to edit. And this is row by column, so I have 2 rows and 3 columns. And I'm just going to type in my numbers like I had. 5, negative 3, 9. And this is 3, negative 3, 3. This is a great tool for when you have simultaneous equations. So now I have my matrix. This is matrix A. So all I have to do is go back into my matrix menu. I'm going to go to math, and there will be a function called rref, which is called row reduction form. And then I have to tell it to do this to my matrix A, and voila. So I'm going to run that, and it's going to say, hey, my single x equals 3, and my single y equals 2. Well, that's what these are. And this is the specific place where those two lines meet. So this is the only solution to that equation. This is a really long example. These types of problems can be as simple as, just this single screen that you're looking at. But we had to build that using our rules of exponents. So this is another tool that we have to solve specific problems. But you have to think about how do we set that up before we move on to that.